Let's do problem 7 on the practice final. We got Spider-Man here. Spinning a web, just hanging here though. He has a mass of 85 kilograms. Hangs from 2 buildings, as shown. What are the forces in these 2 spider web thingies? Okay, so now you want to use a procedure. On the final, I actually say you must use a procedure, and when and that includes step 1. Given, find, and solve is worth a point. So I'm gonna do step 1. Given. I've got spider web here. I'm just going to draw Spider-Man. Well, I guess I can try to redraw Spider-Man. It's kind of fun. So the web is there. The web is stuck on something over here. He has a mass of 85 kilograms. He's obviously just hanging there. The acceleration, we'll just say, hey, the acceleration is 0 in this problem. And this force is at an angle of 35 degrees from the horizontal. We're calling this F2 and this F1. And what are we trying to find? F1 and F2. I'm trying to find what are the forces in those spider webs. I can see them a little bit. And now solve. Now, on the test, if you do this, you've got 1 point. If you don't do this, though, you've lost a point. So, so make sure on the test, when I say use a procedure, you set it up with give, find, and solve. Okay, step 2 is draw the free body diagram. Now, you could try to redraw Spider-Man, but that was too tedious, so I'm just going to draw Spider-Man as a dot. There's Spider-Man, reduced to the simplest version of himself. And here's F1. Here's F2. And then we've got gravity, mg. Right? Gravity is pulling down on Spider-Man. Now, it's really important that you make this drawing under what's given. Draw the problem. Draw the free body diagram separate from that. The free body diagram just shows the forces on this free body, on this object of interest, all the outside forces. Then, and hopefully on your equation list, you've got the, I'll let you write out the 5 steps. Okay, so this is step 2. Now step 3, your x and y-axis. Define what's positive x and positive y. Remember, if it's a inclined plane problem, you will tilt this to match the plane. But for a problem like this, you just leave it like we normally do. And then, look, F2 is horizontal. It's in the negative x direction. Mg is in the negative y direction. But look at F1, right? It's got components. Some of it's in the x, some of it's in the y. So this is F1 cosine 35 degrees. Now, how do I know it's cosine? Is it cosine because it's x? No. It's cosine because it's adjacent to the angle. And then this part right up over here, this is F1 sine 35 degrees. Is it sine because it's y? No. It's sine because it's the opposite from it's the opposite leg from the angle. Now, when we deal with vectors and polar coordinates, yeah, the x component, we always take the cosine of the angle. And the y component, we always take the sine of the angle to find the y component. But in inclined plane problems, the angle is not defined the same way as vectors and polar coordinates. It's defined from the vertical, so the sine and cosine get switched. So to prevent yourself from getting confused, it always works if you just say, hey, this is the adjacent leg of a right triangle. I take the hypotenuse, which is F1, and multiply by the cosine of the angle to get the adjacent leg. And then the hypotenuse times the sine of the angle gives me the opposite. Is that clear to everybody by now? I hope. All right. So I just did step 3. Boom, you got a couple points. Now, what's the next step? Sum of the forces in the x direction equals ma in the x direction. I want to see you write that down. And then I want you to look at your free body diagram and construct this equation. This means add up all the forces that are in the x direction. I look at this. Ooh, I got F1 cosine 35 minus F2. That's it. There's no other forces in the x direction. Equals, well, what is mass times acceleration? But what is the acceleration in this problem? He's just hanging there. He's not accelerating. So this is 0. On an inclined plane problem or a crate dragging problem or something like that, right? I'll give if I say the velocity is a constant, the acceleration is also 0. Here, the Spider-Man is just at rest. Maybe he's caught in his own web. I don't know. You write the story. But so this is true right here. Now, what does this mean? Well, I'm going to say F1 is equal to F2 divided by cosine 35 degrees. So this just gives me a relationship between F1 and F2. It doesn't tell me what F1 and F2 are, but it gives me a relationship between the two. You see, I've got one equation here, or one equation here, but I've got 2 unknowns, so I can't solve it. So what do I do now? I sum the forces in the y direction equals ma in the y. And then I look in the y direction. What are the forces in the y direction? Well, I've got F1 sine 35 degrees. Right? This is pulling up. This is the component of F1 that's pulling up. And then there's only one force pulling down, and that's the weight of Spider-Man. Equals, and then what is the acceleration in the y direction? 0. Oh, this is going to allow me to solve for F1. So F1 equals, well, I'm going to put mg on the other side and divide by the sine of 35 degrees. Now, I kind of messed this up. I solved for F1, but I really should have solved for F2. But that's easy to fix. Now, what is mg? Well, Spider-Man is 85 kilograms in mass, and gravity pulls down on Spider-Man with 9.8 newtons of force for every kilogram of mass. Do I need to make this negative here? No. I already did by making it minus mg, so don't put in another negative because now you're saying gravity is up. And then I'm going to divide by the sine of 35 degrees. See, now I'm doing step 5. See, doing this and doing this, that's step 4 of the procedure. And then step 5 is just doing the algebra to solve for your unknowns. So F1, well, let's see, we're ready for that. That's 85 times 9.8. And then we're going to divide that by the sine of 35 degrees. And we get, ooh, it's pretty big, 1,452 newtons. Could probably round that off to 1,450, but I don't know, I'll leave it like that. So that's one of my answers. Now F2, well, I can solve for F2. I can go back up here. And I really should have taken this and solved it for F2. F2 is equal to F1 cosine 35 degrees. So F2 equals F1, which is 1,452 newtons, times the cosine of 35 degrees. And I get 1,189 newtons. And there's my answers. So that web's made out of pretty strong stuff. Well, actually, that's not that big. Okay. Any questions? Make sense to everybody? Okay. That is all.